For multi-year participants of our forum, did you like the lunch better than last year? Anyone? Yeah? I hope so. Okay. All right. Good. Please let us know on SurveyMonkey. We want to continuously improve things. So Ben Bussey, unfortunately, could not be here. He really regretted that. He had a fairly last-minute request to go to South Korea. A lot of important things going on with our partnerships there, particularly with AES. So he asked me to give the talk. So if you notice that it's an invited talk, I did not invite myself to give it. So what I'm going to be talking about today is giving you an update on the ISIG Science White Paper that accompanies the Global Exploration Roadmap. We've talked about this for, I believe, the last couple of forums, and we're just about there right now. Okay, there we go. So first of all, ISIG is a non-political agency. It's a coordination forum of 15 different space agencies. I think the last time I talked with you, it was only 14. The UAE has been added to this. It works in a non-binding, consensus-driven manner, and so the idea is creating a forum for discussion of common interests and building programs together. And one of the main products of the ISIG is the Global Exploration Roadmap, which was last published about 3 years ago. It's currently in revision, and we're expecting a revision sometime in early 2017. And so this, again, non-binding document is a framework for agency exploration discussions. It focuses on human exploration. So it looks at common goals, objectives, looks at long-range missions and architectures, and then it really is all about opportunities for near-term coordination. So what I'm going to talk about today, to give you a little bit of a background, is all about the reference, 3 different reference missions. I want to emphasize that these are an international consensus. All of this document is an international consensus. So we've gotten a lot of discussion recently. For instance, I gave a talk a number of months ago to the National Research Council, which said, well, isn't NASA's plan to go to Mars? Yes, NASA's plan is to go to Mars. This represents that. It also represents other interests by agencies such as ESA and the other 13 agencies within ISIG. So the reference missions that are referenced in the Science White Paper that I'm going to be talking about are, number 1, a deep space habitat in the lunar vicinity. Crew of 4, initially with annual missions lasting about a month, and then increasing in duration and frequency later on in the decade. And I'm going to talk about science opportunities from that. The next one is a mission to a near-Earth asteroid. And the idea here is using the ARM option B. And so a boulder collected using a set-based spacecraft and then returned to a lunar DRO. And then finally, the third reference mission is to the lunar surface, 5 28-day missions, crew of 4, 1 mission per year, and reuse of the pressurized rover for each mission. And then the rover is moved to the next landing site in between missions. And so, again, just to reemphasize, this is in revision now. I don't have any insight as to what it may look like in the future, but this is what the Science White Paper is based on. So the ISIG bottom line, we had discussions with representatives from the ISIG, I guess about 2.5 years ago right now, and they acknowledged the science community, all of you folks here, as a major stakeholder, and scientific gain, although it might not be the prime or sole driver of human exploration, it's an important beneficiary. And so we discussed the idea of developing a science white paper to go along with the Global Exploration Roadmap, and that's been in development now for about 1.5 years. So the idea is describing the international view of the science enabled by human exploration, engaging the science communities. That has been done. I'm going to be talking about that. Targeting the same stakeholders as in the GER, the 15 space agencies, and highlighting activities that are going to feed forward to Mars exploration. So Mars is clearly still the horizon destination here. And so there's a number of interdisciplinary scientific topics. I'm going to be talking about those a little bit more. We have solicited input from all manner of different subject experts within our broad community, and we have presented this in its various stages of development at a number of different fora. For instance, the European Lunar Symposium, we just had that in Amsterdam in May. It was presented also in Frascati the previous year. It's been presented, I presented this, and Ben has as well at SBAG and League. It was also presented in Nordwijk at the ESA Moon 2020-2030 conference in December. And then we held a workshop that was co-sponsored by COSPAR and the Science Working Group, ISEG, in February 2016 in Paris. And that resulted in a pretty significant change to the asteroid section of the document. So the group is co-chaired by Ben and Jean-Claude Vermes of the European Science Foundation. You can see the membership here. I serve as executive secretary, and Survey also supports the business aspects of getting this white paper done. Where we are in development, like I say, we're just about done. The arrow shows that we're in editing and review. The document has been sent to the 15 respective agencies. We've received a lot of fantastic feedback from the communities. Within the U.S., this has mostly been coordinated by League and SBAG. I was part of the SBAG review group just a handful of weeks ago, and those inputs have been sent in, and so it is undergoing agency review. I know certainly at NASA, and I believe at ESA and other agencies as well. So the way it's structured is that there are two overarching themes, and then we look at science opportunities within each of the design reference missions. And so the two overarching themes are living and working in space and understanding our place in the universe. And so within living and working in space, we have a couple of overarching questions. How do we become a spacefaring species, and how do we sustain life outside of the Earth? And the disciplines involved range from human physiology, life sciences, life support, to ISRU. And then secondly, under understanding our place in the universe, the overarching questions are: how do terrestrial planets form and evolve, and how does life evolve in the planetary environment? And the disciplines here range from astronomy, planetary geology, solar physics, space physics, and astrobiology, as you can see. So now I'm going to go over the science opportunities, just give you a highlight of the science opportunities that have been identified in the document. First of all, with respect to a near-Earth asteroid, this is in reference to the ARM mission. Sample return, number one, provides key science. This is something we can certainly all agree on. Humans present a great opportunity for intelligent sample selection, for optimizing samples with using appropriate instruments to do that. There's a large amount of sample return mass compared to robotic missions. We're talking many kilograms, tens of kilograms, even hundreds potentially, eventually, as compared to a handful of grams. It increases the value of current meteorite collections at JSC and other places, and it provides an archive of samples for analyses that need to be done on Earth. We have increased access to the material. There's going to be multiple drilling sites potentially on the asteroid, on the boulder that is brought back with ARM. We can look at, for instance, different ages at differing depths, and we can also look at problems of interest to human exploration, such as resource extraction. Humans, of course, can aid in instrument deployment and placing instruments on the surface. One thinks here of ALSEP, although in the lack of gravity, it's a different kind of problem. But certainly humans are going to aid in that, and then as well as long-term instrument deployment in situ. And this is going beyond bringing the samples back to Earth. And then finally, there's implications for planetary defense. NASA has just stood up a new office for planetary defense that coordinates with multiple agencies in the U.S. And this will help us understand asteroid structure. So next, we take a look at the humans to the lunar surface, DRM. Of interest to quite a few of this community. Sample return provides key science. I think we would all certainly agree with that, and also with the fact that humans are best at identifying scientifically important samples. I think, Jim, of Dave Scott's wonderful talk at LPSC about the Genesis rock a couple of years ago, and who knows what else we'll be able to find when we finally are able to send humans back there. And this will improve our understanding of impact cratering and provide insight into evolution of the terrestrial planets. And also there's heliophysics opportunities as well to understand the history of the sun. We can also get a much better understanding of lunar volatiles through a human presence, particularly an extended human presence, by recording the flux and composition of volatiles. There's a lot of experiments that have been discussed in some of these meetings. There's opportunity to answer important questions for relating to astrobiology and evolution of prebiotic compounds, and also, there's an opportunity in the human exploration realm to install and maintain resource utilization equipment using knowledge from such missions as Resource Prospector. There's an opportunity to emplace delicate or large astronomical instruments, and I'm thinking, for instance, on the far side, Jack Burns at least was here. I don't know if he's here right now, but the sort of work that he's looking at for looking at the early universe and the formation of the first stars. There's an opportunity there with human exploration and understanding the physiological effects of the lunar environment and human health, and potentially contributing to benefits on Earth is also an important opportunity. We know very little about the effects of fractional G, and also there's important considerations on the toxicity of lunar dust as well. And then of course, going along with that, understanding how plants and other non-human forms of life can adapt to these conditions is important as well, particularly for long-term habitation of the moon. And then finally, the moon is very important in terms of feed-forward activities. This has been a major consideration with the League roadmap, and that would include planetary protection applications. Finally, science enabled by humans to a lunar vicinity habitat. Lunar surface science using telerobotics is an important opportunity. I know Dave Krang and Jack Burns in this audience have worked hard, have been some of the early workers on this, taking a look at intelligent sample selection, for instance, using low latency telerobotics and placement of dipole antennas on the far side. And gaining that experience could be useful for Mars exploration. We just finished, I know many of you were at the Phobos Deimos conference that we just had, and there's a great interest in low latency telerobotics for potential operations of Mars surface instruments from Phobos, for instance. Human-assisted lunar sample return, I already mentioned that briefly. It's this location could be an important staging post for human and robotic missions, and it could provide global access using a reusable lander. And it's important as well to understand the combined effects of radiation and fractional gravity outside of the Van Allen belts. So there's additional science opportunities as well. For instance, using whole image views of the Earth to monitor Earth's climate, astronomical observations, I touched on that already. There's a number of fundamental physics experiments that are enumerated in the draft document, collecting interplanetary material. These are some discussions I've had with Mihai Harani in the past, extra solar system material. And then finally, I touched on heliophysics, and I believe that is it. So thank you very much.
Does anyone have a question for Greg? Oh, come on, I want to throw this. Yeah, there you go. I'm not that good. I'm not that good at throwing. Yeah. I don't want to get...
So I just wanted, if you want to throw it off. So I just wanted maybe just to make a comment. So I'm the ESA representative on the science working group of ISEG-G, and just to say that the significance of this paper is quite important. I think firstly, I hope you see that what Greg's presented in terms of the global exploration roadmap is consistent with what I was talking about before, and that's what's being discussed in the international community about what will happen, what aspirations are for what will happen. What's really important is that this demonstrates that the international sort of community of agencies in ISEG-G is listening to and wants to listen to the science community, and to make sure that what is presented, what comes together between those agencies, is useful for the science community, and that science interests are reflected in the way that exploration roadmap develops and changes over the coming years. So just this is the beginning of a dialogue, not the end of it, and so this will continue.
Thanks, James. That's very important, and this will go to heads of agencies and even higher politically in all the member countries. So I completely agree. This could be a very, very important document indeed.
Somebody close. Who wants to have it?
Oh, there's someone?
Yay! Okay, here you go. 1, 2.
Do I speak?
Just speak into the black.
Right up here?
There you go.
In one of the lines I saw you said to understand the physiological effects of the lunar environment on human health, contributing to medical benefits on Earth. Could you explain that a little bit more, please?
Yeah, certainly. So this is something I've actually been involved in a previous career, as a matter of fact, and there's actually been an institute started to take a look at these things in the state of Kentucky called the Exomedicine Institute. So there's I really could only give you a handful of illustrations, and maybe it's better that we talk afterwards, but there's a number of effects that have been looked at and observed in microgravity and other similar kinds of situations that may have benefit to life on Earth. And the best example that I could give here was talked about by Eugenia Wong, who was one of the finalists at one point for the National Institute on Aging. And I was talking with her, and she said that you look at astronauts coming back from microgravity and space in general, and they have effects that mimic the effects of aging. And she said, we don't know if there's a causal relationship between these two things, between aging and microgravity effects. But she said even if there's 5 or 10% commonality in terms of causality, this could actually have an economic impact, because healthcare is such a huge part of our budget, of $100 billion or $200 billion a year. So in other words, we could pay for a space station every year. And the Exomedicine Institute, I'm on the advisory board for that, has been started to address those sorts of concerns. I'd be very happy to talk with you afterwards some more. Yep. Okay. Very good. Very good. Okay.
Let's thank our speaker again.
Thanks, Yvonne. Thank you. All right, the final talk of our